In this video and the next one, I'm just going to show you a few more algebra tricks for working with some of these limits that involve trig functions where we can use one of these limits. And for the most part, we're going to be using this one. This tends to kill things off and it's not quite as interesting. This is the one that we'll be using most often. But these are the three limits that you may now take as known, that unless I explicitly ask you to derive them, and I might ask you to do that with one of these, but I've told you I would only ask you short answer questions about the derivation of this one. Those are the only ones you can take as given. So anything else you're going to have to manipulate algebraically to make it match one of those forms. So here I've got this. Limit as x goes to 0 of x over tangent of 3x. So I sort of see two problems here. First of all, it's the wrong trig function. I've got tangent instead of sines or cosines. And second of all, the x is on the top. We'll deal. Okay. So I'm going to rewrite this as the limit as x goes to 0 of x over sine 3x over cosine 3x. Because tangent, I know, is just sine over cosine. So tangent of 3x is sine 3x over cosine 3x. So that's getting things in terms of sines and cosines. And now I'm just going to say that's the limit as x goes to 0 of x times cosine 3x over sine 3x. Because the way I would divide by a fraction is to multiply by the reciprocal. And of course, I can just keep that x then on top. So on top I've got x, cosine 3x, and on bottom I've got sine 3x. Now, I'm going to just take a look at that. This is an indeterminate form. Top is going to 0 and bottom is going to 0. But if I take a look, the top is going to 0 because x goes to 0. Cosine of 3x is actually going to cosine of 0, which is 1. Sine of 3x is going to sine of 0, which is 0. So it's the x and the sine factors that are causing the indeterminate form. The cosine isn't really a problem piece. That's perfectly well behaved. That's just going to 1. So what I'm going to do is I'm just going to rearrange things. I'm going to keep the x and the sine 3x together and just indicate that I'm multiplying that by cosine of 3x. Okay. Now I'm going to just let this piece hang out for a bit because I know that's just going to 1. If I can simplify this limit to get that to be a finite number, then I can just use my product rule of limits, take the limit of this piece and the limit of this piece. Okay. See a couple of issues here. So I'm plugging 3x into sine, but I just have 1x on the top. Kind of like that to be the same. The other problem, though, is that it's upside down. So I'm going to have to deal with that as well. I think the simplest way to deal with the 3, let's just multiply by 1 in the form of 3/3. Okay. So I can say that's the limit as x goes to 0 of 3x over 3 sine 3x times cosine of 3x. Okay, and this extra 3 on the bottom, that's just a constant. So if I want to, I can factor that out. Just make sure when I do that, that it stays in the denominator. So I can say this is equal to 1/3 the limit as x goes to 0 of 3x over sine 3x times cosine of 3x. Okay, excellent. I've procrastinated long enough. I've got to deal with the fact that this is upside down. What I really want to do is flip it. I can't flip it. That changes it. I know I can't just change something to its reciprocal. But if I flip it twice, I haven't changed it. So I'm going to take the double reciprocal of that. You might say that's pointless because if you flip it and then flip it back, you haven't changed it. But let's just take a look. If I have a number and I want to take the reciprocal of that number, if my number is 2/3, I would take the reciprocal and I would get 3/2. So there I took the reciprocal by just interchanging the top and the bottom. My number is 2. When I take the reciprocal, I get 1/2. Now I can think of that as I had 2 over 1 and I flipped the top and the bottom, but I can also think of that as a second option for taking the reciprocal. The reciprocal of a number is 1 divided by that number. So I'm going to take the reciprocal of this expression twice, and I'm going to do it once each way. So I'm going to say this is 1/3. The limit as x goes to 0. Now the second factor of cosine of 3x is still just hanging out. We'll deal with that at the end. Okay. Here, I'm going to take the reciprocal, 1 over, of the reciprocal, flip the top and bottom, sine 3x over 3x. Okay. Now, 1 over sine 3x over 3x, if I were doing this division, I would multiply by the reciprocal of the bottom and I would get 3x over sine 3x. I'm liking this. Here now, on the bottom of this fraction, I've got 3x on top being plugged into sine and 3x on bottom. Not quite a perfect match here because I need 1, 2, 3 places. So I'm just going to make a note. As x goes to 0, does 3x also go to 0? Yeah. If x is going to 0, any multiple of x is going to 0. So now I can say, oh, this is fabulous. The top here is just 1. This piece I can now say is going to 1. This piece I can now say is also going to 1 because cosine of 0 is just 1. So I can say this is 1/3 of 1 over 1 times 1. This is just 1/3. Very cool. Okay. Now, one caution here. I kind of let that cosine just hang out for a while. I knew eventually it was going to become 1. Okay. Now, I'm going to just go back to this step here. If I wanted to evaluate that part first, I could, but I would have to say this is the limit as x goes to 0 of 3x over sine 3x times the limit as x goes to 0 of cosine 3x. I would have to formally break it up into 2 separate limits if I wanted to evaluate this one while I'm still working on this one. I can't just say, oh, this piece goes to 1 and just work with this. Let me show you why not. Okay. I know that the limit as x goes to 0 of sine x over x is 1. Okay. This right here is an indeterminate form. Top goes to 0, bottom goes to 0. Since it's an indeterminate form, I have to keep those pieces together. So I can't say the limit as x goes to 0 of sine x over x is the limit as x goes to 0 of 0 over x. I can't just evaluate this piece and then deal with what's left. That's not true, because this limit here would be 0. I can't, if I'm evaluating a limit, I can't just deal with part of the expression and then apply the limit to the rest of it. Okay, I've got to take the whole limit all at once, or split things apart into 2 separate limits. Here, I can't split this into 2 separate limits. This is not the limit as x goes to 0 of sine x over the limit as x goes to 0 of x, because that would put a 0 on the bottom. Okay. So if I want to work with one part, I have to know that it's totally legal to actually separate it into separate limits. You may do that, but if you want to replace this with a 1, you have to first of all explicitly write that that's a separate limit and you're still working with this one. Okay. And that means this has to be a finite number. It turns out it was, okay, so that your product rule of limits that allowed you to separate those into two pieces does apply.